Welcome to electric vehicle classes. The topic for today's discussion is numerical problem on two-quadrant chopper fed DC motor drive using electric vehicle applications. The problem is taken here with two-quadrant chopper. It is excited with 72 volts. The chopper has variable duty ratio D1 and D2. D1 is for switch 1, D2 is for switch 2, and the chopper configuration produces ripple in armature current. To minimize the ripple in armature current, the series filter inductance LF is added, and also the differential ratio or gear ratio is given as 1:1. It means the motor speed will be equal to the vehicle speed. And also observe the given parameter. The wheel radius of the vehicle is 11 inch. It will become 0.28 in meter, and motor rated voltage is 72 volts, armature rated voltage 72 volts, armature rated current 400 ampere, RA 0.5 ohms, LA 8 millihenry, motor constant 0.7, and chopper switching frequency 400 hertz. Right? So it is asked to find a series filter inductance so that worst case our motor armature current ripple is 1% of IA rated. So this is case A. In case B, we will assume the speed is steady state and we will find torque, speed, as well as we will find the condition. We will check whether the condition for continuous conduction mode is satisfied. Write the given data. Battery voltage RA, frequency is given as 400. So my switching period is 0.025. LA is given. Also a clue is given. Worst case motor armature ripple. So when the worst case motor armature current ripple will occur, it will occur only at D is equal to 0.5. We know that this is my ripple. The presence of AC component in DC is nothing but ripple. So this ripples or the swing in the graph will occur to a larger extent. D is equal to 0.5 when compared to all other duty ratio. So let us fix the value of D as 0.5 as per the given concept, and also let us calculate the ripple current here. So the motor armature current ripple is 1% of IA rated from the given data. So 1% of armature rated current is 400 amperes. So it is 4 ampere. So del IA, the armature current ripple is del IA. So this expression is nothing but two-quadrant operation, two-quadrant chopper operation fed to a DC motor. Right? So this is the expression of armature ripple current. So the given parameter, substitute the given parameters. V battery is 72, RA is 0.5, and the value of D is 0.5, and the value of T is 0.0025. So we have the equation in exponential. In order to make the mathematical calculation simpler, let us assume the value of e power t by tau as x. Right? And t is a positive number, tau is also to be a positive number. So it is the ratio t by tau should be greater than 0. As it is greater than 0, always x value will be greater than 1. So now let us substitute e power term in terms of x and substitute the value of t as 0.5 and rearrange the equation. The third term and fourth term in the equation can be combined as 2x power 1 by 2. X power 1 by 2 can be written as root x, and also rearrange this equation in a quadratic form, and in order to find the value of x, let us substitute root x as u, and hence u square is equal to x. So substitute and find the value of u1 and u2 by solving the quadratic equation using the formula minus b plus or minus root of b square minus 4ac divided by 2b. And I am getting the two answers. From this answer, find the value of x1 and x2. And we know that the value of x to be greater than 1. So the second answer is not possible. So let us choose the value of x as 1.11h. Now we know the value of x, we know the value of t. Take natural logarithm on both sides and find the value of tau. So once we determine the value of tau, we can able to calculate the value of LF. As we know that tau is equal to LA, armature inductance, plus series filter inductance LF divided by armature resistance. So when you substitute the given data, we can get the value of series filter inductance required for this condition. To meet this condition is 3.12 millihenry. right? Let us move to the subdivision. To solve the subdivision D, let us understand the given parameters. The tractive torque is given as 24.7 plus 0.0051 wheel speed square, right? And also in the second case, the speed is asked to be maintained as constant, right? As the speed is constant, we know that rate of change of speed is 0. It means omega term will become 0. It is d omega by dt will become 0. Acceleration will become 0. As acceleration becomes 0, we can able to understand that FWA and FLA will become 0. The inclination is given as 0 in this problem, 0 degrees. As psi is 0, the hill climbing force will also become 0. So only the two terms left over is FRR plus FAD. So the given expression is nothing but FRR value is 24.7. It is constant, depends on only mass. And the second term is, we know that 1 half rho A CD V square. In terms of V square, velocity square, we have omega square, right? So it means the first term represents the rolling resistance force or the rolling resistance torque. The second term is aerodynamic drag. So it is, the speed is varying as square of speed. The speed is nothing but square of speed, right? And also it is given in the problem, it is asked to find the value of speed, the constant speed when the duty ratio was equal to 0.7. This is also the condition given in the second case, right? And also we know that for a rotational mechanical system, we can write that the total torque is equal to moment of inertia into the angular acceleration. It is nothing but Tm, motor torque minus the road torque. So d omega by dt is equal to 0. The speed is constant. So we can write Tm is equal to Ttr, right? The given motor is a DC motor, a separately excited motor. So let us write the voltage equations. VA is equal to EB plus IA into RA, and the back EMF is K5 into omega, right? So let us rearrange the equation to write IA. In place of EB, substitute K5 into omega. So we got this equation. Also know that torque is proportional to IA and constant K into IA. Substitute IA in torque equation. So we got the motor equation, right? So this is my armature voltage. The armature voltage is given as 72 volts in the problem. But here the duty ratio is given as 0.7. It is 0.7 here. So 0.7 into the 72 is 50.4. Substitute the remaining parameter given in the problem. K5 is 0.7. RA is 0.5. So now we got an expression for motor torque. And also the gear ratio is given as 1:1. And hence the motor speed will be equal to the wheel speed. Now to find the speed, let us equate both torque and rearrange this quadratic equation, and the speed cannot become negative, and hence take the value omega as 38.91 radians per second. Now this is my speed, my duty ratio 0.7. Now let us check in what mode the chopper circuit is in operation. It is also asked in the question. Let us find the armature current as T by K5. From the earlier equation, we know torque is proportional to IA into K. Torque is equal to IA into K. From this, we got answer of armature current is 46.3 ampere. We know that the ripple current is simply a lesser value. The armature current is 46.3, as it is a very larger value. The ripple current is around 4 to. If the duty ratios change, the ripple current may also change. So the worst case ripple current is 4 ampere. Is it right? So it is very less value. But here we got 46.3. So it represents continuous conduction mode. So let us find the continuous conduction mode. The condition for, let us verify the condition for continuous conduction mode. It is given by V battery greater than or equal to V battery into the duty ratio term should be greater than back EMF. Back EMF is K5 into omega. Calculate, it is 27.2. V battery is 72 volts. The inner term is battery voltage into the duty ratio term. The duty ratio for the second case is given in the problem is 0.7 and the time is switching frequency is 400. So 1 by 400.0025. Substitute the parameter and solve, and it is 49.6. So 72 greater than or equal to 49.6 greater than 27.2. So it means this is a condition of voltages for the circuit to be continuous conduction mode. So it is also satisfied. So from the armature current relation, we understood that we are in continuous conduction mode. Also, the voltage relation says that the vehicle is in continuous conduction mode. That is, the chopper is operating in continuous conduction mode. Right. So we have determined the speed, right, of the speed of the motor, and also let us calculate the vehicle speed. So motor speed multiplied by the radius of the wheel will be equal to the vehicle speed, and it is in meter per second. If you want to convert in kilometer per hour, multiply by 3.6, so it is by kilometer per hour. So in the second subdivision, we had understood that at constant speed, my motor torque will be equal to the tractive torque. So we had able to determine the speed. From the speed information, we determine the value of armature current. So that armature current says in what mode we are, in continuous conduction mode or discontinuous. And also by this relation, we had verified that we are in continuous conduction mode. And then the speed, motor speed multiplied by the wheel radius will give us the vehicle speed. This is what we had discussed. So this problem has been referred from Iqbal Hussain book. You can also refer from the book. This video explains you in detail about the concepts. Thank you. Thanks for watching.